This presentation is titled Natural Language Processing Template Engine. My name is Anton Antonov. I brand myself as a senior data scientist. It's kind of relevant. This branding is relevant to what I'm going to present. This talk is related to the talk I gave on Wednesday about simplified machine learning workflows. The longer title for this talk is Code Generation Using Semantic Parsing of Computational Workflow Specifications via Question Answering Systems. It will be two distinct parts. We're going to look into the problem formulation, what is the big picture, some demo examples. I'm going to discuss the design and I'll walk through the actual template engine, how it works. And I think the walkthrough is probably the most important know-how of the talk. The bring your own templates, this is probably of most interest if you want to utilize the system. And we'll see that we'll have some kind of other additional topics. All right, Zoom doesn't let me continue. Now it did. So what I'm trying to do, the problem formulation is that we want to do a rapid specification of computational workflows. We want to generate relevant, correct, and executable programming code which is based on the natural language specifications. We want to automatically recognize the workflow types. And we want to generate code in different programming languages. The implementation itself is entirely in Wolfram language, but we can generate code for other programming languages. Here is some example. You can see I'm having some simple commands, and I have generated this programming code corresponding to the commands here. Like say the first one, it's very vague. Make a classifier over DS Titanic. You can see DS Titanic has been recognized, and then the rest is just some kind of default stuff. The second command, though, which says use certain data structure, A abstracts, and then you extract 32 topics. Somewhere here, you can see what the 32 topics have been recognized. Now, there's no method 32, right? But this is also related to the limitations using neural networks. Oh, this template engine is based on neural networks, and the templates rigid specified by the user, but then the fill-in is being done through FindTextualAnswer, which is a functionality developed by Wolfram Research, Jerome Loradur. I would like to mention that most of the time, machine learning workflows, where like say 70 or 80% of the time, you're going to be doing classification, related semantic analysis, and so say regression. Now, it's like this Pareto principle, but then within each of these subcultures of machine learning, most of these workflows, what you see here, these workflows most of the time, it's like 60, 70% of the time you're using this. At this point, I'm going to mention this system, the way it is shown here, it's not as applicable for okay, again, something is going on here. It's not as applicable for data wrangling. Now, question answering system, in case you haven't seen this, like you can see this, like this this statement, today it is 45 degrees hot, I think. And we ask the question, what is the temperature? And then we get 45 degrees, right? So when I have my commands here, I'm going to bombard them with different questions and going to extract parameters. More or less this is what is happening. So question answering systems, they can be, there are a variety of ways to do it. It's neural network, using neural networks is one way to do it. I already mentioned my motivation. My target audience is not people who are completely off the street, right? Don't wash masters, the hoi polloi. It is my target audience is people who have technological thinking. This is data scientists wannabes, data analysts, engineers, part-time, full-time data science type of work. Okay, machine learning. So this is actually important because I expect people to be, when they see the generated code, which is executable and correct, they should know how to tune it, or they should be able to figure out how to tune it to their needs. So I would like to mention that I don't believe in this approach using neural networks to do this kind of stochastic extraction of parameters. I mean, in general, to generate this code. I think it's maybe at best it's second best, probably like third best. I do prefer context-free grammars. I'm very biased toward context-free grammars, but I honestly, I'm often asked why I'm doing this in this way, right? With grammars, right? Why I'm not using neural networks. So in a sense, this type of comparison allows to have some objective comparison between the two. I've been mentioning my target audience. So yeah, the context-free grammars I mentioned. Also, what is this, right? And yeah, with neural networks, we can do variety of things. My skepticism about neural networks is that ultimately these are heuristic approaches. They're not heuristics. They always breed special cases and combinatorial explosion of what's going on when and so forth. And it's not clear when you make a system like this. If say this works with GPT-3, is it going to work with GPT-4, right? Now, some of the names I mentioned here, Squad, this is the question answer type of data set. It is used by 1.1. I'm not sure, is it 2? I think it's 1.1 is used in FindTextualAnswer, which is in Wolfram language. All right, so yeah, I mentioned the Pareto principle. Again, notice that I am actually not included data wrangling here. For data wrangling, we do, if I want to generate data wrangling programming code with natural language commands, I do need to use context-free grammars. So this here, it's like, it's an example of the template. You can see it's a template object. This is some sort of pipeline, you know, so I'm basically trying to figure out what are the parameters within this template slots. So, and so when I do this concretize, right, I'm basically asking multiple commands, and then I fill in the template. I should be able to say a different language here, and then it's going to produce a code. Right? All right. So yeah, there's an interface to this system. I'm not going to demonstrate it here, but it's basically, yeah, it's exactly what I was showing. Again, I discussed this in my presentation on Wednesday. For this interface, concretely, right, I am using the Wolfram engine in order to access the templates, to make this template generation. So what is going on here, right? So first, somebody gives me a computational specification, like natural language. Then basically, when you say concretize and the commands, you can also say, you can give a hint in what workflow you want to address. If you give that hint, then we just, you know, continue with getting raw answers and processing the answers and etc. If you don't give a hint, I need to actually have a classifier which tells me, look, this workflow is probably classification or probably semantic analysis, whatever, and this is what is happening here. We're guessing what this workflow is, and I'll show how I make the classifier. The getting of the raw answers, it has this sub-process, which is the question answering system. Now, this particular implementation we're considering, FindTextualAnswers, does use neural networks. It doesn't need to, but you know, there are quite a lot of efforts to do question answering systems without neural networks. I'm actually very interested in those because they're much faster and much lightweight. And with grammars, I can actually use one to the other as a fallback mechanism. It's up to me, say, to decide when in what cases I'm using to the fallback. I'm relying on the fallback. So here, this command, it's a classification command. Now, I mentioned monads and monadic pipelines. This here, it's not monadic code. This here, it's a standard built-in type of commands, but I'm going to use the monadic pipeline, because in this particular case, when you look at this command, make a classifier for the data DS Titanic, using the method random forest, show true positive and false positive rate, you can see how DS Titanic has been guessed. The 0.75 split of the data, this was, you know, by default. Then the actual classifier, it's random forest. Now, true positive rate and false positive rate, they're not exactly recognized. They're kind of standard actually to be used. So I don't think this system recognized the measurements. It just produces, it just by default is going to put this matrix here. Now you can see for the actual measurements, right? It didn't guess that I'm talking about true positive rate and false positive rate, right? It actually put something else here. Well, I'm going to address how is this happening. So let's actually do the walkthrough. What are the raw answers? So you can see, say for the data set, right? I have a question, what data set to use? I have another question, which data, and so forth, right? Now, all of this, for which data, right? All of this, they have different probabilities. These answers have different probabilities attached to them. The one with highest probability, which is this one here, this Titanic, wins, right? So I have several questions for the same parameter. So I have parameter data, I have parameter for measurements, I have parameter for the classifier, right? So if I want to guess what is the data, I have like say 1 or 20 questions, which are just asking what is the data. So because people formulate the questions in different ways, and the way the system has been trained, it makes sense to ask the questions in several different ways. So then you basically you make them compete which one you're going to select. And this goes for everything else, right? You can see using which data set for which data, and so forth, right? Now, then with the split ratio, this is going to figure out what is the split ratio. You can see the split ratio was not specified in the command, but some answer has been retrieved, but the probability is too low. So when I process this, I do have some nominal or minimal threshold for the probabilities in order to select the parameters. If it is too low, it's being discarded. And this goes for everything else, right? So it's same for what classifier, how to classify, what is the classifier algorithm. You can see which classifier algorithm brings random forest with high probability. So this has been selected. So after the raw answers are given, more or less what I described is what, do you see this? What I described has been done with this get answers. So get answers just more or less applies these thresholds and what I mentioned, and extracts the most probable answers for the template. And then we're ready to go, right? So we do. Since I was showing the monadic pipeline. So you see the monadic pipeline is being generated in this way. I think by default, yes. So when you use this command concretize, it is going to generate the pipeline, going to print it out, but also it puts it in the clipboard. So you can use it in the clipboard and do something else with it. Now I'm going to evaluate this. I'm just releasing the halt, right? And so this basically more or less, this executes the command, uses Titanic. I don't know, can you believe me? Maybe you can, because diet and survived has something to do with Titanic, and then we see the receive operating characteristics and so forth. All right. So similarly with Quantile regression, actually, let me evaluate the whole slide here and see what is going to happen. So I put several commands here for Quantile regression because I wanted to illustrate that sometimes small differences in the language, right? In the formulation can bring some kind of wrong results. And you can see here, for example, I'm saying I want interpolation order 2, right? And interpolation order 2 was recognized, right? But then with some slight kind of change using the interpolation order 2, then basically, yeah, we still get interpolation order 3, which is by default, right? So it's not. And there's some other, yeah, I have similar type of questions for the for Quantile regression. All right. So somewhere here, I actually wanted to. This is the bring your own data set. Something happened here. All right. So while is this evaluating, I'm going to go to the next slide, the workflow classifier. So you can see in some of these commands when I execute them, right? I can make a hint. I can say what I want to execute. But I mean, I should be able to do this. This should be also recognized. So presumably, right, if I do this evaluation here like this, just a moment. So something is evaluating in the background right now. So when it finishes, so if I just give the command to concretize, I should expect the function concretize to recognize it and to recognize that it's about quantile regression and then do the execution, right? So this is what is happening here. You can see it's downloading a classifier, right? I have a separate package with the classifier. It's downloading it first, then it uses it to make a classification over the command, right? And guessed it correctly. Okay, so the bringing you on, I have a special GitHub repository for this. So you can see it's just a CSV file. If you want to use this system, you just prepare a CSV file which has this more or less regular structure. This particular template, this is something which is not in the original package. It is about using it's sending mail, right? So I want to make commands for sending mail. And you can see I have this column here, what type of data we're feeding into the system is just questions. So I have questions, the workflow type is send mail, and then I have a question, which API key. And you can see which API key has been repeated 4 times because I want to specify what kind of type I'm expecting. So API key can be a list of strings. This is what you see here. The minimal threshold I was talking about is also specified here. The parameter it's going to be attached to is API key. And there's some contextual words which textual answer is going to bring, but you can remove them. And very often API and key, I consider them to be parasitic words, which maybe textual answer is going to put into the answers. And so forth for the other parameters, right? So now somewhere here, I'm going to go to the bottom of this. I'm actually specifying the templates. And you can see I have specified that I have the Wolfram language template, AutoHotkey. If AutoHotkey is a certain meta language to use in Windows, for example, people who test in user interfaces use AutoHotkey. And then I have used some other language very similar to Perl here. Now, you see the parameters which are being in the template. Mathematica, Wolfram language has the command send mail. Excuse me. Here's the command send mail, and you can see this. This is a string template, and in this string template, I have the parameters to, body, and so forth. All right. So there are some other additional parameters to be given, but after you give the questions and you give the templates, you are ready to go. So I'm going to ingest this CSV file into the system, and now I'm going to call concretize on this, right? Concretize again, produce this code. Let me kind of, yeah. So it basically, yeah, it's like in this command, send mail to joedoe@gmail.com with content random real and so forth, right? Yeah, you can see that to whom has been guessed correctly. The subject, this is a random real call, right? Also has been praised correctly and so forth, right? Okay. Making of the workflow classifier. So first of all, notice that here, I mean, we just brought in this template. So my default classifier in the system doesn't know about it. If you want to include the actual send mail into the classifier, right, you need to redo the classifier. But maybe it's not needed. And so so here you can see, like say I'm calling it with different programming languages, for different workflows. Let's actually, and yes, you can get wrong results. Like for example, this here, it's a recommendations command. I would have expected this to be considered recommendations command, but we get quantile regression. This can happen for a variety of reasons, and we'll see when I train the classifier what it happens. So how the classifier is being made. So the computational workflow types, we have, like say, some set of them. And imagine I have collected probably like hundreds of commands for each of the workflows I'm focusing on. then I have the labels and the commands. I can make a classifier. The problem is that this system hasn't been used by hundreds of users, say, what is the alternative? The alternative is to manually generate the commands. And if we're generating manually, why not write first context-free grammar and then use random sentences generated by this context-free grammar? So this is what I'm doing, right? That's not necessary, but this is how this particular classifier has been created. And so you can see, basically, I'm spelling out the different steps here, like how the classifier was made, what is the database of the workflows with the corresponding tables. Yeah, so obviously, we need to figure out, do we have sufficient textual data? We need to ask ourselves how good are these grammars, how much they describe what people are going to ask. Like this grammar is more or less, it's something I have envisioned so far. So this system here, this is in, you can see there are quite a lot of mathematical package files. And these are context-free grammars written in Bacchus-Nur form. So I'm using those grammars here. I'm using those grammars you see here for latent semantic analysis, whatever it is, neural networks, classification, and so forth. I'm using them to make my presentation is it's here. Oh, not all right. Yeah. So I can take this grammar, right, and this is the grammar itself, and then I can say generate 12 random sentences with this grammar, right? And so now what is convenient here is that because I have the sentences, I know how I generate it. I can just label the data, produce sufficient textual data, train the classifier, and and evaluate it, how good it is and whatnot. And so if you look at, I'm not going to go through the execution here, but yeah, you can, I mean, of course, I need to look in the confusion matrix of this classifier for the workflows. And I think the ROC plots are more informative. You can see that in many cases, we have nearly perfect classifier, right? The perfect classifier is something like, say, it's something like this, right? It's like a straight line here. So you can see it's pretty good, but there's some confusions. So, and we decide to live with it. So alternatively to this classifiers, I can, instead of using Mathematical's built-in or Wolfram language built-in classifier methods, I can use prefix trees. So that produces a much lightweight classifier. And one of the advantages is that I also can use it across different languages because I can export the trees into JSON form and so forth, right? I'm not going to expand too much on this, but yeah, the alternative is a good idea. I don't think I have that much time to talk about the ETOM dog food, but it's an interesting question. Can I actually like, for example, if you are new to this system, this is a valid question, like what are the templates we have, right? Because you don't know. Actually, that should tell me right now that send mail is somewhere here. Well, I hope. And apparently, well, it's not. These are the built-in templates which are being known. And you can say, I have some other introspection. Basically, I can have questions to query the system. Like I can say, show me what is your recommendation specification, right? Or show me what is your template for like latent semantic analysis and so forth. What is happening is that I basically created this text blob, right? Which basically has the information for these textual answers. It's that simple. So I go through the data structures of my package and just form some sentences, and then I can query the sentences using FindTextualAnswer. This is exactly what is happening here. All right, so this would be interesting to show. Some people have been asking me this. So let me see, did I create this? So for example, this here is the latent semantic analysis or not. Okay, yeah. So latent semantic analysis workflow. The only reason I'm using this external process is to show the grammars, and something definitely happened here. And I'm going to Going to redo the process. I think it's an important distinction. And hopefully this time is going to work. So it did. I'm still not sure. Okay, yeah. All right, fine. I'll show it with the Quantile regression workflow. What is happening here, right, is what you see. I can evaluate this monadic workflow you see here. I can evaluate these individual steps. They actually generate into code. And so this is the advantage to use context-free grammars and to use monads. My code with the monads has algebraic structures itself. Because of this, I can do some mappings between the code I want to generate and the natural language. And this can be very convenient, and I can do whatever kind of other stuff in between. We do not need to use monadic code. It doesn't have to be. You can use standard imperative code when you use this system, both with the grammars and with the neural networks. It's just, when I use monads, making the first versions of those, it's much easier. And so this is the end of my talk. So, I mean, I basically mentioned my pessimism already. So I think, it's these are just more detailed list of why I have this pessimism. And thank you for your attention. Do you have time for questions? Or... Excellent question. This is exactly what I don't want to do because I don't believe in this system. But if you do believe in this system, right? And I'm going to go to this last slide. If you do believe in this system, you can actually train it. You can find these thresholds. These thresholds right now, I just scratch my head, 35%, right? But if you have the data, right, you can actually try to study and see which are the most decisive variables in these classifications, find the most appropriate thresholds. And my question is, what is going to happen if you get GPT-4? Or what is going to happen if you get BERT-2? Are these thresholds going to be valid, right? So again, if you believe in this system, you can actually curate it, make it work, right? I personally, I'll just couple it with context-free grammars. The concrete measurements, I do have entity recognition system, which recognizes almost everything which, say, Classify framework has. So if you say true positive or TPR or true positive altogether, I'm going to recognize it as a valid measure and I'm going to use it. This is with grammars, right? So my point is, if I have this kind of failures, I can always, I think with the grammars, I can address them much more adequately. So, and any other questions? Okay, yeah, thank you.